All right, so this is Mr. McMurray. Welcome to Monday morning. Hope you're having a good one. So we have a impulse equals momentum change worksheet. All right. Basically, this one is going to use some things we've talked about, impulse and momentum change, and how those affect each other. You will notice down at the bottom you have formulas. All right, the change in velocity is the final velocity, or the end velocity, minus the initial. All right. Then you'll notice that acceleration is equal to the change in velocity, or final minus initial, divided by time. And we have acceleration is equal to force divided by mass. Okay, so those will all equal the same thing, basically. You get acceleration, the same thing here as you will there. Either formula will work to get acceleration. Just depends if you have force or mass, or if you have change in velocity or time. Now, this one looks very complicated, but really all it's saying is impulse is equal to force times time. We did that. And it's saying that change in momentum is equal to mass times the change in velocity. However, since they're all equal to each other, if it asks you for the change in momentum, but it gives you the force and the time, then you can use that, and it's going to be equal to the change in momentum. If they ask you for impulse, but then they give you the mass and the change in velocity, then you can calculate that and get the impulse. So basically, all of these things interchange with each other, so it should be able to find them. If they give you the impulse and ask you for the change in momentum, then boom, it's just the same thing. You don't even have to calculate it. Impulse equals change in momentum. All right, so that one can be a little intimidating at first, but if you break it down, it will be very, very useful. All right, so we're going through this problem. I'm going to just explain a few things here. So first of all, we have a car with a mass. So I would put an ilm right there above that. Just remember that's mass of 1,000 kilograms. It's at rest at a stoplight. If it's at rest, that means its velocity is, that's correct, it is 0. Good response. I'm glad you said that. All right, it is 0 meters per second. I'm not going to write meters per second because it's hard for me to write with this, but you get the idea. All right, now, is this the final velocity or the initial? Well, it is going to be the initial. So VI is that. When the light turns green, it's pushed by a net force of 200 newtons. So that's obviously force, technically net force, but you get the idea. All right, oops, sorry, that should be an F. Okay, net force. And for 10 seconds, that's going to give you time. Okay, so if you want to find acceleration, you have two possibilities. You have force divided by mass. Do we know the force? Yes, we do. Do we know the mass? Yes, we do. So we could use that one. Now we have this one, which had final minus initial velocity divided by time, but it does not tell us the final velocity. We know the initial velocity, we know the time, but we don't know the final velocity. So we're going to have to use force and mass to get that acceleration. Okay. Now you're going to have to be careful. Make sure that when you cancel out units, that you cancel out the right ones and end up with the right ones. All right. Remember that, and this will probably be handy. Write this on your paper somewhere. That newtons are the same thing as kilograms times meters over seconds squared. Probably should just type that in, but there you go. And so that might help you when you start canceling units here. Okay? All right. Now, once you do that, it wants to know the change in velocity that the car experiences. Well, now that we know acceleration and we know time, we can just plug it into this formula and solve for change in velocity and so on. Okay? Now, impulse, change in momentum, final velocity, you should be able to figure that all out using the formulas down below. Now, it says if the car continues at the same speed. Okay, so key thing right here, it is going at the same speed. That would be a constant velocity. We're going to assume it's a constant direction as well. So same speed or constant velocity. Okay, now it's going to ask you a couple questions. Think about it. This is the same. That's very important. Okay, now, whatever the final velocity was and all that stuff is still going to be true for it while it's going at this speed. Okay, then the brakes are applied and it comes to rest in 4 seconds. So now we have a new time. Okay, and what is our final velocity going to be? It's coming to a rest. Okay, so This is our velocity, but this is going to be our final velocity because it was moving, and so now it's coming to a rest. So our final velocity is going to be equal to 0 this time. Our initial velocity would be whatever velocity we came up with that we were going up here. Okay, so keep that in mind. All right, then I think the rest of it here will, you can kind of find it out without thinking. Now, we're thinking, if you think it over. All right, now on the back, it says beware. A disease known as formula fixation. In other words, people just say, hey, it's like a math problem. You get numbers, you throw them in a formula without even thinking about whether they really belong, whether the answer makes sense or anything like that. All right, basically, don't do that. Okay, so first of all, you can answer some of these without even having to do any calculations. And even if you do calculations, you should think about, is this a logical way to do it? Okay, but basically you should have these, and these are using the formula, the same formula down here at the bottom, okay, and that we talked about on the other page. Now the last one here is a little more challenging, but you can do it. It is required. It is not a optional assignment, okay, optional question, doesn't say bonus here. Okay, you have a 10-kilogram hockey puck, that is its mass. Okay, it's at rest, so we know its velocity or initial velocity is 0 meters per second. Okay, now it's going to tell you, so we're starting off at 0 meters per second. Now it's going to tell you how much force and for how long it's going to feel. All right, and what you need to calculate is the change in what? Momentum? Velocity? What do we need to find? We need to find out how much it changes, okay? So since we have force and time, and we have mass, and we need to find out how much it changes its velocity so we know what speed it's going at next, we could do force times time equals mass times that and solve for change in velocity. Once you get that change in velocity, then you go for the next length of time, what happens to it, and calculate how much it changes again. And then finally do it one more time. And then you add those or subtract those from each other to get what the final velocity would be. And you should be able to do that. Like I said, it takes a little thinking, but it's not really all that hard once you get to going on it. All right. I think that pretty much kind of explains how you're going to do them. So I think you're ready to, like little birds, go fly on your own and make Papa, no, not Papa Bird. Okay, that sounds like a big bird. Anyhow, make Mr. McMurray proud. All right. So good luck, enjoy, and I will see you hopefully tomorrow. Have a great day.